Welcome to part 2 now of SPHS chemistry, acids and bases. And today now on this video we're going to be looking at what are some common acids and bases, what are the properties, and then indicators, things that change colors according to pH on these acids and bases. Okay, so first off, just kind of looking at some common acids, things that are around your house: lemon juice. Okay, we got some vinegar and baking powder and vitamin C. The most common bases you may not know is baking soda. It's a good base. They use that a lot in medicine if you have an upset stomach. Drain cleaner is a very strong base. Ammonia to clean. A lot of your cleaning agents are made out of bases. Okay, so some of your most common acids, I already mentioned this in the last video. Sulfuric acid is the #1 produced industrial chemical. We talked about economic indicators. How do we know how our economy is doing? Well, however much H2SO4 is being produced in our country will tell us whether or not the economy is growing, doing well or not. Okay, it's used in too many things to even describe. Phosphoric acid, I already talked about that too. It's used in colas to kind of react and caramelize the sugar as a chemical reaction, but it's also used a lot in fertilizer because phosphorus is very important for plants. Okay, nitric acid, it's most commonly used for explosives. It's also used in fertilizers a lot, and so a lot of fertilizers can be converted into explosives as a result of that. And then hydrochloric acid, you may not know, but hydrochloric acid is what's your stomach acid, and it's a strong acid, which is why if you have a very uncomfortable issue where you have to throw up, there's that burning sensation whenever you throw up because of the HCl in your stomach. People that struggle with bulimia damage the esophagus because of the continuous exposure to that HCl. Okay, it's used for pickling, just kind of, that just means it's kind of getting the impurities out of it. It's also what you add to swimming pools. If any of y'all have a pool or have worked at a pool, you have to use muriatic acid. This is the commercial name of hydrochloric acid. You buy this at a pool supply store, and this is what you pour in the pool to adjust the pH. And it's actually the pH of the pool that causes the eyes to burn when it's when the pH isn't right. It's not the chlorine in the pool that makes your eyes burn. It's having a bad pH. Okay. So muriatic acid is the same thing. They also use it to etch concrete. If you ever going to do house remodel, whatever, you have to treat the concrete with hydrochloric acid just so that it'll take the stain and things. And then the most common is acetic acid, which is vinegar. We eat that all the time. And so obviously it's a weak acid, very dilute. So common bases, okay? NaOH is probably the most common base. Its commercial name is lye. It's used in drain cleaners. It's used in industry to treat inside of tin cans. So the acid from the tomatoes doesn't affect the tin. There's just, there are a bazillion different uses of sodium hydroxide. Now, milk of magnesia, this is used as an antacid. If you have an upset stomach, it's also a laxative. It's called milk because it's a white suspended solid. I talked about that in solutions a little bit. So it kind of looks like milk, but it is a suspension because the particles are very big and they will settle out, which just kind of brings me to this. This was the demonstration I did earlier with the red silver chromate got produced. It's all sitting, it all settled out to the bottom, and then they're left of the solution that doesn't settle. So a solution, the particles are tiny, but in that suspension, they're big. So in this bottle, you have to shake it before you drink it because the particles all settle out because it is a suspension. It is not a solution. But that's why it's cloudy, it looks like milk because the particles are big. Solutions are always clear, not necessarily colorless, but clear. Okay, and a lot of bases are used to make soap. Okay, and so soaps tend to be basic, and so we'll talk about and see the characteristics and the properties. Okay, now never ever use the taste test to determine whether or not something is an acid or a base. But acids that do have a sour taste. So when you have a Granny Smith green apple, that's maleic acid in there that causes that taste. When milk goes bad, the lactose sugar is converted into lactic acid, and so it's sour milk. Okay, so anything that has a sour taste to it probably has some kind of organic acid in it. But we don't ever want to use that. Back in the day, in the 17 and 1800s, that's how they would test. They would actually take sips of it, but they did massive amounts of damage to the body in doing that. Okay, we're going to talk about indicators later on. Some acids react with metals. We've talked about this in terms of a single replacement reaction. We did a lab with this where we put magnesium into sulfuric or hydrochloric acid, but that's the replacement of hydrogen by an active metal and releases the hydrogen gas. But again, remember, the metal must be more active than hydrogen on that activity series if this reaction is to occur. If we put gold into sulfuric acid, nothing's going to happen because gold is less active than hydrogen. So, contrary to Hollywood, not everything reacts with an acid, but most metals do react with acids to produce hydrogen gas. Okay? Obviously, acids react with base. That's the neutralization reaction, and you're always just going to get some kind of salt. Now, salt, remember, is any ionic compound, is salt and water. So we're going to neutralize that. We're going to look in reactions in the next part a little bit more in detail how that happens. Okay? We already talked about in the previous video that they're electrolytes because they dissolve as ions, and so as a result they conduct electricity. And acids, we're going to, the very last thing in part 5 of our video series on this, we're going to talk about the pH scale. But most of y'all know that for an acid, 7 is neutral. Anything below 7 is going to be acidic. Anything above 7 is going to be basic. Okay? So we have that pH scale. We'll learn more about that later on. So properties of bases, everything's going to be opposite. Acids are sour, bases are bitter. Back in the day, parents used to wash kids' mouth out with soap as a punishment if they had a dirty mouth, okay? And so it was a punishment because the soap, it wasn't harmful to them, it just tasted so bitter, it was just tasted nasty, and so you didn't want to have that done. Nowadays, that probably could be considered child abuse, but back in the day, that happened to kids all the time. Get your mouth washed out with soap because you have a dirty mouth, okay? Now, obviously, bases, just like acids, they change colors of indicators. Okay, they do feel slippery. Okay, acids don't feel slippery, but that's why soap is made from a base. It feels slippery and slimy. Okay, they react just like bases react. Acids react with bases. Bases react with acids. It's the exact same thing. It's like a commutative property. It doesn't matter the order. They neutralize acids, neutralize bases. Bases neutralize acids. Okay, they also dissolve as ions, so they're electrolytes, and we already said that their pH is going to be greater than 7. So you should be just familiar with the basic properties of acids and bases. Okay, so you can kind of go through on this one here. You know, just remember you're going to have to just do your single replacement reactions. Okay, and then you can just kind of do your comprehension check. So if you want to stop, pause the video right now, and do that, that would be great. All right, so what are indicators? Indicators change colors according to pH. If you put it in an acid, it's one color. If you put it into a base, it's another color, okay? And so if I'm looking at most common indicator is litmus paper, okay? So if I have red litmus paper, which I just happen to have some red litmus paper right here, okay? If I take a piece of red litmus paper, see if I can grab one piece, okay, and I get some acid. I have some sulfuric acid right here. Now you never really want to dip the litmus paper directly into the acid because then whatever solution you're testing gets contaminated with litmus. But if I just take this and I touch it to red litmus paper, well, it stays red. It does not change. But if I take some sodium hydroxide, which we know to be a base, hydroxide with a base, I'm going to take a stirring rod, clean stirring rod, just kind of stick it down into here, get it wet. I'm going to just use the other side of this red. And if I do that and I touch it now, hopefully you can see that it turns into a blue color. So litmus, if it's an acid, red litmus stays red, but blue litmus turns blue. Okay, I just touch it over here with the base. Okay, now, so you also have blue litmus paper. Oh, and this one has tape on it, and it's going to be hard to get off. I didn't realize this one had tape on it. There we go, brute strength. So I take a piece of blue litmus paper, and I do the same thing. Okay, so I take my base, and I touch it to blue, and it stays blue. It does not change. Okay? But on the other hand, if I take my acid and I touch the blue with the acid, let's get a drop on there. Okay? You can see down here, hopefully you can see, it's turning red where I touched it with an acid. So litmus paper is blue in a base, red as an acid. You can always remember that BB, blue is a base, red is an acid. Okay? So, litmus is by far the most common. Now, a better form of litmus paper is what we call pH paper, which is neither red nor blue, it's just this color. And what happens here then is that depending upon the pH, it's going to change all different colors. So it's much more versatile. So you can get the pH anywhere from, what does it go down to? It goes all the way down 1 to 12. We can get the pH of this. Okay, so I have some dilute vinegar right here. So if I touch this, okay, it's still pretty red. Okay, so it's still going to be, you know, down here on a pH around 2, and I just match up the color. So this is universal indicator paper. We like this better because it gives us a little bit more than just acid or base. It gives us an actual pH. Okay, so there's different types of those litmus paper. It's really not called litmus paper because that's not just litmus, but a lot of people still just call it litmus paper. A lot of times in politics, you'll hear people talk about a litmus test, and that's just, you know, it's just kind of a reference to this as far as whether or not it's going to be an acidic or a basic solution. Okay, now, phenolphthalein. If we were going to be again in a lab, and we were going to be doing a lab, okay, if I took some vinegar, I take some vinegar, just put it into a beaker, okay, and I put a couple of drops of phenolphthalein. Now phenolphthalein is a great spelling word. Look at all those wasted letters in a PH, TH, anyway, it's a great spelling bee word, okay, but here's some phenolphthalein. And if I just put 2 drops into here, in an acid, it stays colorless, stays clear. Okay? I just spilled some. Let me clean that. But if I add some base to this and neutralize the acid and we have more base then. So as I add this and add more base, let me get out of the light here. So then it goes, oh, did it go pink? Let's see. Is it going to stay? Ooh, it went away. Okay? So all the OH minuses are looking for the H pluses in there, and they almost found it, but we still have more H pluses than OH minus. I do not trust this to be 6 molar NaOH. Okay? You just keep adding. Okay, so now we have more base than we do acid. So when the pH is greater than 7, actually somewhere around 9, then it turns this pink, magenta, fuchsia color. Okay, so it's colorless in an acid, it's fuchsia color in a base. Now if I added more acid back to this, let's see if I can just take some of my acetic acid, add it back to this. If I can neutralize that back, or if we want to go quicker, for the sake of time, y'all are complaining that my videos are too long. Okay? Woo. Doesn't want to neutralize. But once we add more acid, then it goes back colorless. So phenolphthalein is an indicator. It changes color according to pH. It's pink It's the most common when you do an acid-base titration, a neutralization reaction. Unfortunately, we don't have time this year to do that, but it's in a normal year we would do one of these reactions, and you know when you've exactly neutralized it when one drop caused it to turn pink. And so phenolphthalein, it's an important indicator. It's one that's used all the time. Now here's the one with cabbage juice. Now you saw me. I made the cabbage juice ahead of time. Okay, and so it has a color scale here. So if I go through and I have just, let me see, I'm going to turn this off right now so I'm not fighting the light. Okay, so hopefully you can be able to see it. So I'm going to take, here's my cabbage juice. If I just start, this is what the juice looks like to start with. It's kind of purple. If I just add tap water to this, okay, dilute it down a little bit. Okay, if I just add tap water, woo, I think I hit something. This stirring rod had a little bit of base into it. So I'm gonna add a little bit of acid back to this to try and see if I can get it back to the color I wanted. There it is. It's close. Need a little bit more tap water now. Okay, we're gonna see if I had stirred it with something other than a contaminated stirring rod, it would be this nice, almost Spain Park, not quite Spain Park blue color. Now if I just take one drop of my vinegar solution, we can get this kind of this deep purplish color. And then if I go and I use strong acid, ooh, we can get a nice red color. Then if I go and take a little bit of ammonia, we talked before that ammonia is a base. So if I just put a couple of squirts into here with the base, I can get this nice green color. And then if I take my strong base, my sodium hydroxide, and I put it into here, keep going, get that pH way up high. Then we get this nice yellow color. So I'm hoping that you can see this. So we have a yellow and a green. Pretty much neutral is blue. Slightly acidic is purple. Very acidic is red. So this is all just normal cabbage juice. Cabbage that you buy at the store acts as a great indicator. And so you can, if you ever needed to know, when you do a MacGyver, you needed to know what is the pH of a solution, you can kind of get an idea based upon the color from the cabbage juice. It's just kind of neat that something in nature can make all those pretty colors. That just really kind of excites me right there. I'm not quite sure why. I guess that's why I teach chemistry. Anyway, so that's pretty cool. All right, so cabbage is another indicator. It's just a natural source of an indicator, and there are your different kind of colors that I just kind of created for you on that. Okay, so there are a ton of different types of indicators that we could use. Okay, phenolphthalein is the most common, but if you get into higher level chemistry, you'll use different values for these. And so they all just change colors at different pHs. And so depending upon what pH you're trying to find, what experiment you're doing, you'll want to use a different type of indicator. Okay? Now, this is the wide range indicator paper that I already mentioned right here. That's where you just kind of match it up with the colors. And then the easiest way to identify pH is just with a pH meter. You just stick it in there and it just tells you what it is. And this is kind of the more modern way, the way we do it most of the time now. Okay? So that's all there is for this part. And so you can just kind of look and do these comprehension checks and kind of go from there. And this one was easy. All right? If you're enjoying these videos, please feel free to subscribe to my page and like the video. Hope you're having a great day.